Earthquakes are one of the many hazardous and destructive natural catastrophes that may occur all over the world. And as the recent earthquakes that devastated Turkey and Syria illustrate, they are clearly something that should be a source of concern for people everywhere. Over 11,000 individuals lost their lives in the most recent earthquake disaster. However, the number of fatalities is still rising several days later. Earthquakes can range from being unable to feel anything at all to a mild rumbling to an apocalyptic level of damage that generates a wave of horrible calamities over a wide geographical area. The range and strength of earthquakes can change dramatically. However, what causes earthquakes to occur? How can it be determined or stopped? Where are earthquakes most likely to occur, and what role does climate change play in their occurrence? What factors contribute to the occurrence of earthquakes? The most basic explanation for an earthquake is that it occurs when two sections of the Earth slide past each other along a fault. These blocks of the planet's crust are called tectonic plates, and the outermost layer of the Earth's crust is called the lithosphere. The tectonic plates are what constitute the Earth's crust. These plates are continually being pushed and pulled in various directions, much like a jigsaw that is always being rearranged, because they are all moving in unison with the rest of the world. Plates come in a wide variety of shapes and sizes, and they are typically separated into three categories: major plates, minor plates, and microplates. These plates range widely in terms of both their size and the number that comprise them. The largest of these plates covers an area of around 103 million square kilometers. These plates are continuously moving, however they aren't connected to one another in any manner. Each one has its own unique set of boundaries, which are distinguished by more than one fault. As the plates move and shift around, they occasionally touch and become temporarily linked to one another at their limits. When the plates begin to move apart, these faults continue to be attached to each other. As a result, they continue to rub against one another, eventually resulting in the accumulation of a great deal of stored energy and stress. As time goes on, they separate from the plates as the plates continue to move, releasing all of this pent-up energy in the form of seismic waves that physically rock the planet. The first one is the seismic belt that goes around the Pacific Ocean, and is also known to as the Ring of Fire. This horseshoe-shaped zone is 40,000 kilometers long and stretches from south of New Zealand through Indonesia, Japan, the point of Russia's Kamchatka Peninsula, and then along the west coast of the Americas, and maybe as far south as Antarctica. It is named for the shape of the zone, which resembles a horseshoe. According to the United States Geological Survey, USGS, these regions are home to the majority of the world's largest volcanic eruptions and earthquakes. These regions also account for 81% of the world's strongest earthquakes. The movements of the tectonic plates in these regions occur all the way around the Pacific Plate, causing severe volcanic eruptions and earthquakes. The Alpide Belt is the next one, and it extends all the way from western Indonesia into the Himalayas, all the way into the Mediterranean, and finally into the Arctic. 17% of the world's most powerful earthquakes are recorded to have occurred in this region. However, regardless of this, earthquakes can take place in any part of the world. But have you ever wondered that pumping too much water from our groundwater will cause a significant crack on the surface of the Earth? The United States has been pumping so much groundwater for so long that massive cracks are beginning to appear in the ground in several places of the southwestern United States that extend for kilometers. These enormous fissures, sometimes known as cracks, have been discovered in a number of states, including Arizona, Utah, and California. Groundwater is one of the primary sources of potable water on Earth. It is responsible for the production of about half of the world's drinking water and for approximately 40% of the world's irrigation. However, humans are pumping groundwater at a rate that is greater than the rate at which the planet can naturally replenish it. Joseph Cook, who studies Earth fissures at the Arizona Geological Survey, told Insider that these cracks are caused when an excessive amount of groundwater is pumped up from the natural aquifers that lie beneath the surface. This causes the earth to drop and creates the openings. Cook explained that the fissures are not something that would naturally occur. It's something that we've brought into existence, he said. It's our doing. According to Cook, the fissures are indications that there is stress within the earth. They surround enormous flat portions of the land that have sunk due to the absence of groundwater, which provided support for the land. In the valleys that are formed between mountain ranges, fissures are a regular occurrence. These cracks have the potential to cause significant damage to structures such as homes, roads, canals, and dams. Likewise, they pose a risk to both people and their livestock. Since at least 2002, the state of Arizona has been keeping a close eye on this issue, which has been present for a considerable amount of time and has been widely publicized. The Arizona Geological Survey has so far mapped 169 miles length of fissures across the state. According to the findings of an inquiry that was published not too long ago in the New York Times, the cracks are indicative of a crisis on a national level. The water level was measured at tens of thousands of different locations across the United States for this investigation by the Times. According to what was found, the aquifers, which are responsible for supplying around 90% of the water systems in the United States, are being depleted to such an extreme degree that they may never be able to recover. During the last 40 years, significant decline has been observed in nearly half of the sites that are being monitored. According to the Times, throughout the course of the last decade, all-time lows were reached at 4 out of every 10 sites, because the rate at which groundwater in the United States is pumped out is greater than the rate at which it is replaced. According to a study from the Times, the recovery of aquifers may take hundreds or perhaps thousands of years, if it is even possible for them to recover at all. According to Cook, some of the sites in Arizona are already beyond repair and cannot be saved. According to him, the rate at which we utilize water has been so consistent and intense for such a long period of time that it has not provided sufficient time for rains to refill subsurface aquifers. According to Cook, basically, some of these basins in Arizona have progressed so far beyond that point that it is never going to bounce back. According to a law professor at the University of Tulsa and a specialist on water issues named Warija Bowman, a crisis is well on its way to becoming a reality when climate change is factored into the equation. According to the Times, rising temperatures around the world are causing rivers to recede, which forces farmers to rely ever more on groundwater reserves as their primary source of fresh water. Since the year 2000, the amount of fresh water carried by the Colorado River, which is a major source of water for farmers in Arizona and throughout the Southwest, has dropped by almost 20%. According to the Climate Reality Project, the world temperature in the Colorado River Basin might climb by another 2 to 5 degrees Fahrenheit by the year 2050, which would result in a reduction of the river flow by between 10 and 40%. The absence of regulation in various parts of the country is one of the primary obstacles that must be overcome in order to address the problem of overpumping. According to the Times, the United States federal government has essentially no restrictions in place to prevent groundwater pumping, while individual states have standards that are lax and vary depending on the region. There is not an exemption made for the state of Arizona. According to the National Audubon Society, a significant portion of the state's groundwater has been unregulated for the most of its history and has functioned on a first-come, first-served basis for the entirety of its existence. According to Cook, this indicates that there is no restriction placed on the amount of groundwater that may be used, and people are free to just drain the groundwater supply until it is exhausted. Likewise, it is unusual to stumble into studies of groundwater conducted on a nationwide basis. The majority of the time, researchers zero in on a specific origin or locale to conduct their investigations. As a consequence of this, the severity of excessive groundwater pumping across the country is not as easy to notice, which may help explain why there is such a limited amount of regulation on pumping. In the meantime, damaging practices such as cultivating crops in arid regions are permitted to continue. According to Cook, these cracks will continue to widen if we do not alter our behaviors and permit underground aquifers to refill themselves according to their own natural cycles. As long as we continue to use more than what naturally recharges, we are going to have this problem, he went on to say later. As Charles Francis Richter says, as seismologists gained more experience from earthquake records, it became obvious that the problem could not be reduced to a single peak acceleration. In fact, a full frequency of vibrations occurs. We must be prepared at all times. You can suggest topics you want to see next in the comment section below. Please subscribe to Weather Collapse if you want to know more and be updated on the latest news about natural calamities or disasters happening all over the world. And don't forget to like today's video. We'll see you in the next video.